Welcome to this explainer on the AI revolution. Today, we're going to completely shatter how you view human progress and the future of artificial intelligence. Based on the deeply researched and honestly fascinating, we're taking a look at the very real road to superintelligence. If you think the future is just going to be a slightly shinier version of today, well, you're in for a wild ride. Let's jump right in. To figure out exactly where AI is taking us, we really have to understand how human progress actually works. So imagine grabbing a guy from the year 1750, a time when, transportation ran on hay, power came from the wind, and long-distance communication literally meant firing a cannon. Now imagine dropping him into our modern world and just walking him down the street. You show him glowing smartphones, massive highways packed with speeding cars, airplanes casually crossing oceans in a few hours, and the fact that the collective knowledge of humanity is just floating in the internet. The sheer shock of this inconceivable sorcery wouldn't just blow his mind. The overwhelming contrast would actually literally kill him. But think about this for a second. What if that 1750 guy, assuming he somehow survives the shock, wanted to play the exact same trick on someone else? He hops in a time machine, goes back the exact same distance, 250 years, to the year 1500, and brings a guy from back then into his world of 1750. Now, the 1500 guy? He'd definitely be surprised. He'd see some new ships, maybe learn some mind-bending things about physics, but he wouldn't die. The jump in human progress between 1500 and 1750 was just so much smaller than the staggering, massive leap from 1750 to today. And this brings us to a really brilliant concept called a die progress unit. Basically, the amount of progress needed to shock someone from the past completely to death. For our 1750 guy to shock someone to death, he couldn't just go back 250 years. He'd have to go all the way back to hunter-gatherer times, roughly 12,000 BC. So a die progress unit used to take 100,000 years. Then, after the agricultural revolution, it took about 12,000 years. And today, it just takes a couple of centuries. This actually reveals a massive, fundamental flaw in how our brains are wired to view the future. We intuitively think of history as progressing in a straight, linear line. We base our predictions for the next 30 years on what happened in the last 30 years. But human progress doesn't work like that. It accelerates exponentially. As futurist Ray Kurzweil's law of accelerating returns points out, advanced societies progress at much faster rates simply because they're already more advanced. So we're not moving in a straight line at all. We are standing right on the edge of a steep upward curve. Section 1. The 3 calibers of AI. The evolution of intelligence. Okay. Let's dive into how this exponential growth applies directly to artificial intelligence by breaking it down into 3 specific calibers.
First up, we have artificial narrow intelligence, or ANI. This is AI that is highly specialized in just one single area. It's like a computer that can definitively crush the world chess champion, but if you asked it to figure out a better way to store data on a hard drive, it would just stare at you completely blankly. It is an absolute master of one specific domain and utterly, hilariously useless outside of it. Now, you might hear AI and immediately think of futuristic sci-fi robots, but the truth is, we live in a world completely run by ANI right now. We interact with it every single day without even realizing it. When you route a flight, when your email magically filters out all that spam, when Amazon eerily recommends the exact product you were just thinking about, or when Wall Street algorithms trade millions of stocks in milliseconds, that is all artificial narrow intelligence working in the background. It is practically the primordial ooze of what is about to come. The next step on this evolutionary ladder is artificial general intelligence, or AGI. This refers to a machine capable of performing any intellectual task, reasoning, planning, and abstract thinking just as easily as a human being can. And AGI isn't just good at chess, it's good at literally everything you are good at.
Section 2. The hurdle of human-level AI, or AGI, the grand challenge. Getting to the second caliber is our current grand challenge in computer science, and honestly, it is spectacularly difficult. But what makes building AGI so hard isn't what you'd intuitively expect. Notice the fascinating contrast between these 2 columns. Things that seem incredibly hard to us, like doing high-level calculus, running complex financial market strategies, or calculating endless chess moves, are mind-numbingly easy for computers. But things that are effortless for us, like recognizing a dog, walking up a flight of stairs, or just reading the letter B in a weird, messy font, are insanely hard for computers. Why? Because evolution spent hundreds of millions of years secretly optimizing our biological software for vision and movement.
We just don't realize how complex it is because our brains process it all completely effortlessly. So how do we clear this immense hurdle and actually achieve AGI? Well, first we need massive hardware computing power. Current estimates suggest we need around 10 quadrillion calculations per second just to rival the raw capacity of the human brain. And the absolutely incredible thing here, we are already hitting that mark. The world's fastest supercomputers, like China's Tianhe 2, have already blown past this astronomical number. That raw hardware power is rapidly becoming an everyday reality. Now, with the hardware in place, engineers basically have 3 distinct software strategies to actually make these computers smart. Number 1, we can just plagiarize the brain by painstakingly reverse engineering its neural networks. If that doesn't work, we move to number 2, simulating evolution. This uses genetic algorithms to naturally select and breed the best code over millions of rapid iterations. Or finally, number 3, and this might be the most promising path of all, we code a computer whose only job is to research AI and improve its own architecture. Essentially, we make the test take itself.
Section 3. The leap to superintelligence, or ASI, beyond human limits. Let's see how this all builds, because this is exactly where our linear thinking completely fails us. Once we reach human-level AGI, the computer isn't just going to politely stop there and remain our equal. Because AGI is built on a computer, it inherently has massive advantages over biological, carbon-based brains. Think about it. It operates at the speed of light. Its memory size can be physically expanded endlessly. It literally never gets tired, and it can instantly sync its collective knowledge across a global network. Because of these built-in advantages, AGI will rapidly evolve into the third caliber, artificial superintelligence, or ASI. This is an intellect that is much, much smarter than the best human brains in practically every single field. To fully grasp how sudden this leap will be, we kind of have to check our human ego at the door. From our perspective, the intelligence gap between a village idiot and Albert Einstein seems incredibly massive, right? But notice how, on the grand absolute spectrum of intelligence, all humans fit into a tiny, narrow little band. So as AI zooms upward toward us, we'll see it as just getting a bit smarter for a machine. But once it hits the lowest level of human intelligence, it is definitely not going to stop and hang out.
And this is the crucial point. Through recursive self-improvement, the AI will experience a massive intelligence explosion. It reaches human-level intelligence. Then it uses that human-level intelligence to rewrite its own code. It becomes Einstein-level. It then uses that Einstein-level intellect to make even bigger, faster leaps. It absolutely rockets past human comprehension. This isn't something that takes decades. It could happen in a matter of days, hours, or literally even minutes. Which leads us to a pretty chilling reality. As a superintelligent AI achieves essentially godlike powers, we are going to be entirely at its mercy. An ASI could be capable of manipulating individual atoms to cure aging, end all disease, reprogram the weather, or, well, end all life on Earth. To an artificial superintelligence, completely rewiring our world would be as trivially simple as flipping a light switch is for you and me. Which brings us to the ultimate existential question you really need to take away from this explainer today. We are standing right on the precipice of an exponential curve, about to give birth to a superintelligence that will forever alter life on Earth. So, when we unleash this unprecedented power, will it be benevolent or will it destroy us? That is, without a doubt, the most important question of our time. Thank you so much for joining me on this explainer. Keep learning, and I'll see you on the next one.